Hi everyone. So I'll be continuing the computer networks lecture, and today I'll talk about is vPc. So vPc is like for Nexus switches. Nexus switches includes a feature called virtual port channel, which allows that two Nexus switches can create a virtual switch, which is called vpc domain, which this feature this allows vpc peers to provide a logical two port channel to a remote device, as in, like, if there are two switches and there are, sorry, yeah, so these are switches and these are devices. So these can be the port channels, and so both vpc peers, as in the switches, are configured independent of each other, and only two nexus can participate in a vpc domain. So in this one, these devices are also nexus switch, and X. So the connection between these two are and which allows the two nexus switches to connect to each other uh, using port channel is known as virtual port channel, and this the in between the virtual switch that is being created is called vpc domain. So what the profit of using this is that it eliminates stp block ports and provides faster convergence upon link or device failure. So um, yeah, and yeah, okay. So for vpc there are three main components. One is peer keep alive link. Second is vpc peer links. Third is vpc member links. Okay, so for vpc fundamental, let's have two switches, let's say nx2 and nx3, and let's say that nx2 has lower role priority, and which means that it is a primary and operational primary device, and the other one is secondary and operational secondary device. Okay, now in case, let's say, now in case the nx2 gets reloaded, now nx3 becomes the primary and operational device. So when nx2 completes its boot up and initialization process, it again has lower priority, but that does not preempt from nx3, which means that at this stage nx2 becomes a primary device but not an operational primary device. It still will be an operational secondary device. nx3 will remain in that state unless nx3 is reloaded and shut down. Okay, so this is how the election of primary and secondary devices happen in vpc domain. Now so the first component is vpc peer keep alive. So in this one, it is not mandatory to configure like VPC peer keep alive. We can use the management board, which has the management IP addresses. If you have reachability between the management IP address, you can use that to be used for peer keep alive as well. So when a VPC peer becomes unavailable, a whole lot like timer starts as soon as the VPS peer becomes unavailable. So this is what VPC peer keep alive is, and yeah. So there are some terminology that we need to first look into, and then we will like further talk about the peer keep alive and everything. So let's say that there are two switches, Nexus switches, and both are connected via port channel, and there is this, then there is one switch, two switch. Now this is like this, and this is completely like this. So this is the complete architecture. Now this is said to be VPC peer keep alive, which means that if when like a peer VPC peer becomes available, that the NX1 and Nexus 2, they both are not unable to communicate, and they are unable to pull each other. A whole like new live timer starts as soon as the VPC peer becomes unavailable. So this is VPC peer link. Now this complete will be called as vPc domain. This is vPc peer link. Now this is vPc peer. And let's do another small sub aggregation, and this sub aggregation, this is vPC member port, and these are configured VPC. So this is the whole architecture, and the complete VPC domain is a pair of VPC switches in a VPC system. VPC peer is just a VPC switch, one of a pair. VPC member port is one of a set of ports that form a VPC. So yeah, so VPC, the port channel between VPC peer and the downstream devices, is known as VPC. So in this case, the downstream devices are also switch, and the above ones are NX1 and NX2. Both are connected, and that's the way it's connected is VPC. And VPC peer link is used to synchronize the state between VPC peer devices. These are also known as Nexus R devices only. And the last one is VPC peer keep alive link, is the link between VPC peer devices, and VPC VLAN. So any of the VLAN carried over the peer link and used to communicate via VPC with a peer device. So VPC VLAN is all those VLANs that has been configured uh, over the peer link, and it is used to communicate via VPC with a peer device. And non-VPC VLANs is any of the STP VLAN that is not carried over by the peer link. That is non-VPC VLAN. Now there is another concept called as CFS, which is Cisco Fabric Services Protocol. Now, this protocol is used for state synchronization and configuration validation between peer devices. So there is orphan devices, and orphan device is a device which is on a VPC VLAN but only connected to one VPC peer and not to both. And orphan port is just the port as an interface which connects to an orphan device. Now, VPC domain, there can be only two switch peers in a VPC domain. The Nexus switch can have like regular port channels and VPC interfaces at the same time. Both a Nexus peer switch uses the virtual LACP system ID for the VPC peer member link, and one can be the my primary and the other can be secondary. We know the election between the primary and secondary is based on lower priority. If the priorities are same, then lower MAC address is preferred, but there will be no preemption that takes place in identifying the primary device. So the concept of like operational primary and secondary primary is introduced. Now we were talking about the VPC peer link, peer keep alive. So it is used to monitor the health of the like peer VPC devices. It is sent every second, and the heartbeat packet is around 96 bytes, and 1 Gbps link is sufficient. If the peer link fails, connectivity is checked across the VPC peer link. A holdout timer starts as soon as the peer is deemed unavailable. That is the one that we were talking about, peer keep alive. Then during the hold timeout period, the secondary VPC device ignores any VPC keep alive message to ensure that the network can converge before action is taken against VPC interface. After the hold and time expires, as mean like it's obvious that the primary device is not going up, so the timeout timer begins, which is default by 3 seconds. If a VPC peer is not received during this year, the VPC interface on the secondary are shut down. Now, VPC peer link is the second component which is used to synchronize state and forward data between VPC peer. It must be on a 10 GB, like around 10 Gbps. It is typically configured on a port channel to ensure sufficient bandwidth for traffic between VPC peers. And in case of modular Nexus switch, it is recommended to spread links across different line cards. I'll be continuing this video in the next